Hi, my name is Garret McKerricher, and I'm at the King Abdullah University of Science and Technology in Saudi Arabia. And we're going to look at using the Dymatics 2800 printer to print out electronic parts like a circuit board or an antenna. And in this example, we're going to look at kind of like a printed circuit paper, because we're going to print conductive ink on paper. We start off with Agilent ADS. You could use any software to create a layout. We're going to take this layout file, convert it into a bitmap image that can be read by our printer, and then we're going to use like silver nanoparticle ink to print on paper this pattern. Next, we're going to heat it up in an oven so that it becomes conductive, and that'll be our printed paper. So start off with ADS. We've created this layout. We're going to export it to a Gerber file. So we could have used, different ways of converting it into a bitmap, but the way that we're going to show is from a Gerber and then to a bitmap file. So I specify Gerber drill file here. Export it. Then I need to convert it into a bitmap file, and I use a software called Magic. And from this Magic software, I open up that Gerber file that I just saved with ADS. So now we have basically a pattern in our Magic software. The thing with Magic, the reason that we use it is because we can specify exactly the drops per square inch that we want to print out. So in the options, we can set exactly the corresponding number of drops per square inch that we want for this image. So why this is important for when we're printing out a single drop, it has a specific diameter, and we want a conductive line. We want the drops to overlap like something like this, so that the drops will just overlap a little bit. And the distance between the center of this drop and this drop is the drop spacing. And we change the drop spacing depending on the different substrates and how big the drops of ink are that we're using with different inks. So these drops per square inch correspond exactly to the drop spacing. And there's a sheet in the printer manual that basically tells us this drop spacing. And we're using a drop spacing of 20 micron, and that corresponds to a DPI setting of 1270. So next we just hit OK, save this file as a bitmap. That's it. Now we take this file and we're going to plug it into the printer. Okay, so now we're in the lab, and this is the desktop printer that we use in the lab. And we've just taken a USB from upstairs with the file that we generated, the bitmap file, and we put it into the computer. The computer is hooked up to the Dymatics printer. So just like a regular desktop printer you'd have at home. It's just hooked up to the computer, and it's a little bit different than your desktop printer because it has this stage on it with 5 micron accuracy of placement. This is called the platen, the stainless steel plate, and it can move up and back, and it can also rotate, and this way you can align your pattern and the drops will drop where it wants. This printer does raster scanning, so this is the cartridge holder, this component here, and it's going to go up and back and work its way down the platen to fill out the pattern. So we'll just turn the printer on right now. This is the Dymatics Drop Manager software, which controls the printer. When it first starts up, it does a kind of a calibration. You have to make sure nothing's inside of the printer when it does this. So now the stage just moves back and forth, and the cartridge holder moves around, and it does its initial calibration. Alright, now the printer is ready to use. So we can load that bitmap file that we had previously. We just go to Tools, Pattern Editor, Bitmap Images. And this is the bitmap pattern converter. So from here we load the file that we had upstairs, open bitmap, and here's the image that shows up in the software. Now on this screen we can change the number of layers. Let's say that we wanted to print one pattern with 1 layer of ink, and then you wanted to increase the amount of ink, so you would just print right over top of that with another layer of ink. So you can do that here with the layers count button. You can increase it to however many layers you'd like. There's also the drop spacing is set within this program. So because upstairs we did the bitmap image with 20 micron drop spacing, we're going to do the same thing. Okay, this tab is for placement and tiling, and we can multiply the image. So if you wanted to make 5 of these images instead of just having the one here, we just increase this count. And you can see all the images get duplicated. However, that's going to take more time to print, so we're just going to show one for this example. Also, you're able to pick a reference point on the image. So this kind of tells the printer in reference to the image where it will start printing. So for example, if we picked the top left point of the image and set that as our reference point, that's where the first drop of ink is going to land. So when we pick that point on our platen, that's where the image is going to start being printed. And now we just save this file. Alright, next we need to set up the printer to print. So we can open the lid and install a cartridge. So these are the cartridges that we use. We buy them from the Dymatics company, and they're disposable. They cost between $150 depending on the nozzle size that you buy. And they come in two parts. We'll show you after how we take them apart and put the ink in them. And they just snap right into the printer. So this is a cartridge holder. We just snap them in and out. Also, there's cleaning pads that we use because sometimes there's ink that builds up on the bottom of the cartridge. So the cleaning pad is just like cloth material that the printer dabs on to clean off the excess ink. Okay, now I'm going to go over there and show the cartridge put together. Okay, so this is the Dymatics material cartridges that we're going to use with this printer. I mean, there's other companies that make their own cartridges that go with their own printers. This is just for the Dymatics. This is what we're using. And the cartridges come in two parts. So there's the cartridge head, and then there's the ink reservoir. And instead of opening a new one, I'll just show an older one that we have. So this is a cartridge head that's been used, and this is the cartridge head, and this is the ink reservoir that's been used. And what we do when we take a new one out, we physically just take a syringe and a needle. Hopefully I don't stab myself. And we're going to use commercial ink for this example, but there's all different types of ink that you could use. So this is a silver nano-particle ink from Sigma Aldrich. And we just basically open this up, draw out the ink, and then before we fill it in the cartridge, because we don't want large particles to clog the nozzles, we use a filter, and we're using a 0.2 micron Teflon filter, and we put that in the needle. Imagine it was filled with ink. And then we physically just put the ink into this cartridge. And Dymatics cartridges have this locking mechanism so that once they are put together, they're stuck. What we do is there's two tabs here, and we just snip off one of the tabs so that we can reopen and close them. So if you want to refill the same cartridge with ink, it's easy to do. Then we just put them together. They just snap. That's that. So this cartridge that we have right now, this was filled for the first time on February 2nd, and now it's May. So we've used this cartridge quite a lot and refilled it. And you can see that there's actually quite a bit of ink leaking around, and it's quite dirty. So, I mean, this cartridge is probably on its kind of last legs, and we might want to throw it away and get a brand new cartridge. But we'll try and print with it and see how it goes. Okay, so back to the software. The first step is that the printer asks you for the cartridge settings, and inside of here is like the voltage waveform. Because it's a piezoelectric printer, it uses a waveform to eject the ink. So we have like a preset waveform that we use for this type of ink, and it has to be tailored for the ink that you're using. I'll just show you the waveform here. So here's the waveform that we are using, and this can be changed. All these different points can be changed. So this is a voltage, and the time along the x-axis is the time, and the y-axis is the voltage. So this is our jetting waveform, and you can change the settings of this waveform with these controls here. Also, there's a non-jetting waveform, and this is just kind of to tickle the ink when it's not being used, so that it's kind of stimulated so it doesn't kind of settle to the bottom, or basically so that it will print while it's in an idle state. So the next part is selection of your printing pattern. And we just select that pattern file that we chose before. And it shows you a little picture of the pattern on the side so you don't get confused. And the next step is to load your substrate on the plat. So the substrate we're going to use is Inkjet, HP Inkjet paper. But we could alternatively use like plastic or glass or whatever you'd like. And the platen has holes in it with a vacuum. So when the vacuum's turned on like it is right now, you put the paper over top of it, align it on the platen, and it'll suck it down. Oh, the vacuum isn't on. There we go. So now that sucks your paper down flat. Okay. So now that we've loaded our substrate, it asks what's the thickness of the substrate. So you can set the height above the substrate that you want to print. If you make it too high, the drops actually start to waver and they won't land where you'd like. So you'd like to print as close to the surface as you possibly can. So we're going to choose 500 microns. This is also where you set the temperature of the platen. So I'm printing at 30 degrees Celsius, but it goes up to a maximum temperature of 60 degrees. Okay. Just as a final check, the last screen just asks, what the thickness is. This is the temperature, this is the pattern that you're using, and these are the settings that you're using for the printer. Then what I normally do is I choose my point on my printer that I'm going to print, and I use the fiducial camera button to do that. So inside of the printer, you have this camera right here, which is a fiducial camera, and it shines a light on the paper, and there's basically a cross you can see in the software where it's pointing at, and you can pick the point where you want your pattern to start. There's also another camera over on this side, And there's a function within the printer that you bring your cartridge over here and you can actually see the drops as they're coming out of the inkjet head. And we'll show you that in a second. So now from the fiducial camera, I can go anywhere on the paper that I'd like to start. So now I'm kind of somewhere in the center of the paper. I have kind of a small pattern, so this is fine. So I could print here, for example. So to print here, I hit Set Print Origin and choose that position. And because I also use the reference point within my pattern, I also choose my reference point and put it in the same position. So I'm going to start printing there, and that's going to be where my pattern reference point was as well. So now I'm going to close the fiducial camera. I've picked my place on the paper to print, and I go to the drop watcher. So this will show me if my cartridge is actually going to work. So here, right now there's 16 nozzles on these cartridges. And you can choose any of these 16 nozzles to print with, or you can print with all of them if they're all working. So we can see that the drops are coming out of the nozzle on position 8 and 7. And I can shut this movie mode off, and it just does a strobe. So you can see how fast these ink drops are coming out and what they look like. You can see that 8 is on kind of an angle and unstable. So I definitely wouldn't use that. Six is also not looking great. It's not too bad. And I generally print at a velocity of 9 or 10 meters a second for this ink. So if I say the delay is 100 microseconds and there's distance markers on this screen, so if the ink drop started at 9, I'll just change this. You can also focus this camera by using these arrows. So here we're starting at 0, and if I look now 100 microseconds later, I'm down at about 800 microns. So I'm just going to increase the voltages. In this screen you can increase the voltages of each of the printing nozzles individually. So I'm going to increase 8 just a bit, or 7. So that it hits 9 meters a second. Okay. Also 6 has become unstable now. I think because this cartridge is getting old. So I'm only printing with the one nozzle 7. So within the cartridge settings, you need to tell it that it's only going to print with number 7. So I say that the first jet is 7, and the last jet I use is also 7. So only one jet is going to print. Inside of here, you can also set the temperature inside of the cartridge. So with some inks, you might want to use a higher temperature. Depends on the viscosity and the characteristics of your ink. You can also set this meniscus vacuum, which is the vacuum inside of the cartridge head. So, you know, if you didn't have a vacuum inside, the ink might just fall out depending on the ink. So this keeps the ink inside of the cartridge. There's also cleaning cycles that it can run. So while you're printing, maybe you want it to print for 1 minute or 10 minutes, and then it will go over to its cleaning pad and clean off any excess ink. You can also get it to purge out some of the ink in case it's been clogged. Okay, so we're just going to save these settings. I'll save in the drop launcher. When you're using a reference point, you have to have the fiducial camera open in order to make it use that reference point. So I just reopen the fiducial camera and hit print. And it asks, do you want only one jet to print? One layer? Yes. Now it starts printing. Okay, that's it. Okay, just to expand a bit on the waveforms, they're not actually that difficult to make, and the Dymatics comes with a bunch of standard waveforms for different inks as a good starting spot. Basically, you have this piezoelectric material, and you're applying this voltage to it. So, in order for it to drop a good drop, you have these different phases, typically 4 phases, and you are gonna, squeeze the ink, let it come out, squeeze it more, and this is enabled to drop a good drop of ink. When I get a new solution that I'm gonna print, I basically take one of these standard waveforms, and it's really trial and error just to, move the timing and the amount of voltage that you're going to put on it in order to get good drops. And then I go back to the printer and see how it's printing and then modify it again. And it just takes a bit of time going back and forth. Just another point about the cleaning cycles. There's 3 different options to clean the cartridge. One is spit, one is blot, and the other is purge. So spit means that it goes over to the cleaning pad and just drops the ink. Blot, it goes over to the cleaning pad and actually pads the cleaning pad. And purge you use when the cartridge is blocked, basically, and it applies a bunch of pressure to the cartridge and purges out all the ink of all the nozzles. And sometimes that's necessary if you're not getting the ink to jet out. Like, that's it, right? So this is the finished printed paper PCB, and after it's done printing, we put it in an oven or on a hot plate and have to heat it up somewhere between 100 and 200 degrees Celsius. And we do this because this ink's silver nanoparticles. So you have solvent and silver nanoparticles. We drive the solvent off and dry it. Then the silver nanoparticles become fused or packed together, and that gives you the conductivity from the ink. And this is a regular laboratory oven that we use, and we just set our samples inside and turn it on. That's it.